Okay. Hi, I'm Geraldine Massoud.
And I'm Sam Felix.
And we have our Hot Wheels leading the way. Okay, our science standard is KPS2, and it is analyze data to determine if a design solution works as intended to change the speed or direction of an object with a push or a pull. For our lesson, the materials you'll need is Post-it notes, toy cars labeled A and B, 2 ramps, tape, 3 washers, or something heavy like a quarter, a weight experiment recording sheet, pencils, and a balance scale.
Okay, so in our 5E lesson plan, in the Engage section, we'll start off with the Post-it note check-in, where teacher will have 2 different pictures of cars on the board, one bigger than the other, with the question, which car do you think is faster? Students will stick the Post-it note inside of the car, and they think that they think will be faster. In a think, pair, share, students will be asked to share with their elbow partner what they thought and their reasoning. The teacher will gather students to the front of the classroom to show the model set up with the 2 racetracks and the 2 cars labeled A and B. Prior to watching which car is faster down the track, the teacher will weigh the cars to determine which of the 2 cars is heavier, car A or car B. Students will need to pay attention to the car that gets down the track faster and determine if it was the heavy car or not. And the driving questions are going to be, how do you think adding weight to the car will change its speed and why? And will the car slow down or speed up?
Okay, for the Explore portion of our 5E lesson plan, students will then gather around the teacher to make another race with different predictions. The teacher will give students the weight experiment recording sheet and circle if the slower car goes faster after adding more weight to it. At the end of the racetrack, students will add a long piece of tape to ensure they know which car makes it to the finish line first. Students will add weight to one of the cars 3 separate times after an initial race without any weight. All students will record which car made it past the finish line first, which will tell them whether or not adding weight made the slow car go faster. So an example of the weight experiments recording sheet is this sheet here, where it says prediction. It says, I think we will need, and students will circle either 1, circle 2, or 3, and it says washers to make the car travel faster. So that's the prediction. And then the results is I found, and again, they will circle either 1, 2, or 3. And at the bottom it says washers are needed to make the car travel faster. So students will write their name and then make a prediction. So they can say, I think we need 2 washers to make the car travel faster. So they'll circle their number 2. And for the results, once they find out, they can say it took, for example, 3 washers are needed to make the car travel faster. And again, the students will need to circle either 1, 2, or 3. And for the explain portion of our 5E lesson plan, students will conduct their own experiment as a whole group. Will answer the following questions by raising their hand. Which car did you think would go faster? What car made it to the finish line first? Do you think adding even more weight might slow the car down? So instead of having the students write down their answers, the teacher will actually have the students raise their hand. And so she'll ask the question at least a few times in order to get responses from the majority of students. So now it's time to see the demo video. I'm going to exit out of here. And this is the video of the students doing the lesson.
Okay, watch where the tape is. Which one crosses first? Racers to your mark. Get set. Go. That time it was B, wasn't it? Okay.
As you see here, the students are able to, the teacher actually says it's either car A or B, and the students have to record again on the weight experiment recording sheet to follow their predictions. Okay, excuse me.
Oh. Oh.
Give us just a moment. We're having technical difficulties. It's going to be okay. Not a problem. Mild technical difficulty. We can work through it all. Okay.
Okay, now go to, yeah,
Perfect.
elaborate. Phew. Okay, so in the elaborate section of the lesson plan, in the Think, Pair, Share, students will discuss with their elbow partner the following questions. The following question: what if we were to change the steepness of the ramp? Instead of it being on top of a table, we change it to the top of a chair. Do you think the speed will change or have the same result? We'll give the students 1 to 2 minutes to discuss the question and their answers with their partner. Okay, and after elaborate, we'll give the students a brain break. There's no sound. No, that's the best part. Are you muted?
So this portion of the lesson is actually the video is a little bit too long to play, but we wanted to give you just a couple of minutes. Sorry, a couple of seconds to see the video itself. But students will need to stand up and just kind of shake out their wiggles and kind of, you know, after an exciting event, bring them down a little bit by using this brain break. Okay, and so the evaluate portion of our 5E lesson plan, we decided that as a ticket out, students will be asked to give one fact or information from the activity. It could be anything. Students, the teacher can ask what they've learned, which car went faster, if their hypothesis right or wrong, if they thought that one car was going to slow down, or if they thought that the washers weren't going to make an impact. So instead of the students actually continuing to write down, the ticket out would be one fact as they're walking out, whether to lunch, recess, or as a ticket out home. And the teacher is able to do that portion of it. So for our modifications and adaptations, we decided to use materials that would be like wooden cars, a bigger ramp, maybe lowering the ramp setting to begin with, a cardboard ramp, or make it an outdoor activity setting. Students are able to actually do that in a group outside, just to have a smaller groups and maybe work within their table group. And they have more space to do so outside. And for our modifications or adaptations for our neurodiverse students, we thought that a student with autism that has autism and ADHD would actually benefit from our modifications, because students are able to get up and move around the classroom. Students will also be able to stand up, sit down, lie down to see which car crosses the finish line first and move around. The lesson plan is also designed to take advantage of students with ADHD strengths, because they are able to work with others and can have a different thinking area to work in. So aside from being in the classroom, when you do a modification, you're able to give the students a different a different environment in which they can work in, which would be outside. And that would work well for our neurodiverse students. And I think that's it. Yeah, that's it. So that's our lesson plan. Thank you so much for watching.
Thanks, guys.
Thank you. Hold on.